There are 3 ways to tune the LS electric servo systems. Offline tuning issues 3 position commands to the motor, and from that, it can estimate the inertia of the load and calculate all the needed feedback loop gains and related parameters. This is the one you'll use most often because it's super quick and easy, and it does a great job with minimal hassle. It's called offline tuning because it doesn't require an external controller to generate position commands. That is, it tunes offline from the external controller that may or may not be connected to the servo. Online tuning is the exact same thing, but it can use the external controller to generate the position commands. It can also use the drive's internal indexer to generate move commands. This allows you to tune to the actual motion profile your system will be using. Manual tuning allows you to manually adjust the tuning gauge yourself. Now, no one in their right mind would ever do a manual tune from scratch, of course. There's just too many things to keep in mind. But it does allow you to tweak the auto-tune results or just take a peek behind the curtain for educational purposes. In this video, we'll cover the offline auto-tune, and we'll take a quick look at how to access the manual tuning stuff. Now, we're not going to do a manual tune. That would require a whole series of videos all by itself. And frankly, manual tuning just isn't necessary because auto-tune does a great job and it's quick and easy to do. Here we go. Let's go to Setup and return to Factory Settings just so you know exactly where I'm starting from. Yes, we really want to reset the drive. Give it a few seconds, and it's done. Hit this guy to reset the drive's controller. You could also power cycle the drive. Yes, we want to do that. Okay, we have a clean drive. Now we just click on this tuning fork button to go to the tuning dialog. In offline tuning, you have 3 controls: rigidity, direction, and distance. Rigidity determines how aggressive you want to make the tuning gains. It's a 1 to 20 scale, and I usually like to start with a mid-range rigidity. So we'll set that to a 10. Direction determines which way you want the motor to start spinning. Remember, the positive direction is determined by how you set things up. We did that in the quick start videos, so watch those if you need a refresher. Distance determines how large the position command is. This slider goes from 1 to 10. The max move is 400,000 user units. You'll usually want to start with a small move and then gradually increase it. So let's set that to a 2 for starters. So now we just make sure our machine is clear so nothing gets hurt when it starts to move, and hit this tuning button. But before I do that, I have the scope set up to monitor the actual position of the motor with auto scale off and a vertical scale set to 400,000 user units, which I know is the max move. The X-axis tab is set to continuous trigger, and 20 milliseconds is fine. I'll go back to the Y-axis tab and hit start. Hit the tuning button. Stop the scope. We see the drive issued 3 position commands, and from that, it estimated the inertia ratio and calculated the loop gains and related parameters. Now, these are just the main ones. There's a lot more you don't see here. Well, that's it. We're done. If you want a larger move command, well, just move this slider. How about a mid-level move? Oh, maybe 5. Start the scope. Hit tuning. Stop the scope. We saw the motor move a lot farther, and the move commands on the scope are also larger. The inertia and gains really didn't change much. So just for fun, let's push the distance out to 10. Start the scope, hit tune, and stop the scope. Yep, the motor moved a lot farther, and the position command looks a lot larger. But the inertia is still the same, and the loop gains really didn't change much. All of which means the drive has a pretty good idea of the load it has to handle. Well, since the distance really didn't seem to have any impact, let's reduce the distance to 5 and increase the rigidity to the max. Now, in a more rigid system, we expect to see more aggressive gains, right? Well, let's see what happens. Start the scope, hit tuning, and stop the scope. And sure enough, the gains are much larger when we compare them to the gains we got with the rigidity set to 5. And that's all there is to it. Think about it. We just tuned the system multiple times in the span of what, 30 seconds? It just doesn't get much easier than that. And all of these parameters are already in the drive. If you ever want to see what's in the drive, just hit the read button. Now keep an eye on this inertia mismatch. I put an oversized load on the motor, and you can see it maxed out the allowable 3,000% or 30-to-1 mismatch this system can handle. and the position waveform got wonky. Another clue things aren't optimal. The closer the mismatch is to a perfect 100% or 1-to-1 mismatch, the better. But realistically, a goal of 10-to-1 or 1,000% mismatch will give you a very responsive system that'll get you accurate and reliable positioning. Now, one side note, our scale went from 0 to 400,000 because the position register was set to 0 when we reset the drive. Now, if you're doing tuning on a system that's been running, this max number will be 400,000 away from whatever position you start at. If you want to force the starting position to be near 0, just go to Homing, select Mode 35, and hit Home. That doesn't move anything, it just resets the position register to 0. What if you want to manually tweak things? Easy. Just click this guy and you see all of the tuning related parameters at a glance. Over here, you're just seeing the main parameters and can't manually change them. Here you see and can tweak everything. And of course, you can always view all of those parameters in a flowchart format so you can visualize how they impact each other. You can also do online tuning with this full parameter set. We'll talk about that in the next video. Just know that this is a little confusing. The gray block here means this is off, and on means click this to turn it on. The green bar says this is on, and click here to turn it off. Now, why would you want to do online tuning? Well, because you can tune to the actual position commands your system will be using, and not just these 3 internal commands created by the drive. And you'll be able to see the difference between the commanded and actual positions on the scope, which makes it easy to visualize how the gains are impacting your system's performance. Again, this offline tuning is really all you'll need for most applications. But if you want to try online tuning, join me in the next video where we'll walk through it. It's identical to what we just did, except you now have control over the speed, and you'll be able to see the difference between the actual and commanded waveforms on the scope. Meanwhile, click here to learn more about the LS Electric Servo systems. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe and hit that little bell icon so you'll be notified when we publish more videos like this one.